going to talk a little bit about sets and Venn diagrams and things like that. So some terminology that we use with sets. So a set, just a collection of objects which we call elements. So the language that we use with sets. Okay, we could have a listing set, and that's simply where we list all the elements inside the set. So set A I've called there is 1, 3, 5. We could have a describing set, whereas rather than listing them, we just describe what they are. So set A, I could say, oh, that's the first 3 odd numbers. So it's the same set, just a different way of describing them. Equal sets, sets that contain exactly the same elements. Set B is 5, 3, 1. Well, that's got the same elements as set A, 1, 3, 5. So they're equal sets. The empty set is a set that contains nothing, also called the null set. The universal set is the other end of the scale. That's a set that contains everything. Subset is a set within another set. So the set C there, which is just the number 5, it's a subset of both A and B because it's contained inside those two sets. And then intersection, well, that's what they have in common. So if I now call another set D and it's 2, 3, 4, then the intersection of A and D would simply be the set 3 because 3 is in both A and B. Union is then the combination of all the elements in both sets. So the union of A and D would be 1, 2, 3, 4, 5. That contains all of the elements. Complement, same as we saw with probability yesterday. Complement then is the ones that are not in the set. If my universal set was just the first 6 integers, then the complement of A would be 2, 4, 6, because A was 1, 3, 5, so its complement would be the other 3, 2, 4, 6. Notation, the symbols that we use to save ourselves some time. The 0 with a slash through it, some of you might have seen it in computing and things like that, it's often used there, is the null set or the empty set. Another way of doing it is simply having the braces with nothing inside. So it's the empty set. What looks like, I guess, an E, or a sideways U with a stroke through it, just means is an element of. So 3 is an element of the set we called A. The absolute value signs, or sometimes N with parentheses, is the number of elements. And we saw that yesterday when we were talking about the size of the sample space and things like that. The U on its side is the symbol for subset. So all those sets we defined before, C is a subset of A, C is also a subset of B. Now B is a subset of A, but they were also equal sets. So you see how there's like a bar underneath, like we would with an equal sign. We put that there. And then the null is a subset of A. The empty set is actually a subset of every set, which is weird because how can something have nothing in it? But it just does. It's a subset of everything. Intersection, so the symbol is the upside down U, and union, U for union. Complement, again, same as we saw with probability yesterday, the bar on top. There are another couple of notations, a little rarer, the apostrophe, so A apostrophe, and just a C for complement. Okay. That brings us to this idea of Venn diagrams, getting a picture of the sets. Now, the universal set we represent with a rectangle. So the rectangle contains everything. And then all the other sets are inside the universal set. So the sets we were just talking about could be represented this way. Okay? So it was the numbers 1 to 6, B was the set 1, 3, 5, C was just the set 5, so it's totally inside B. A and B were equal sets, they both had 1, 3 and 5. So I've placed B inside A, but I could have just as easily had A inside B, it doesn't really matter. And D was the set 2, 3, 4, and they intersect there. So subset C. C is a subset of B, so there it is, totally inside B. Intersection, so that's the bit they share. Union is both of them together. Disjoint sets, that's what we talked about yesterday as mutually exclusive, so if they have nothing in common. So C and D are disjoint sets. Okay, so how do we use that with probability? It's another way of putting a sample space together and solving probability problems. Here's our rule. The number of elements in A union B will always equal the number of elements in A plus the number of elements in B minus the number in the intersection, because you've double counted the ones in the intersection. You've counted them in A, you've counted them in B as well. So because you've double counted the intersection, you need to take it away. 2020 HSC question then. So history and geography, two subjects that we could choose to study. There's a group of 40 students and we know this information. 7 study neither history or geography. 20 study history and 18 students study geography. So the first part of the question was, a student's chosen at random by using a Venn diagram. They did give you the option to do it another way if you wanted to, so say or otherwise. Find the probability that the student studies both history and geography. Well, there's a Venn diagram, the universal set, and I've got 2 subjects, geography and history, and I'm assuming there's some crossover there, so I've drawn an intersection point. I guess we need to work out how much to put in each section. Now, I know there's 7, so let's go back to our information. There were 7 that don't study either. So I know there's 7 sitting outside those 2 sets. Now, how many were there altogether? 40 altogether. So I can use my counting rule to work out the missing information. So the union, so the 2 together, must be the number in G plus the number in H minus the number in the intersection. Now I know there's 33 altogether because there's 7 that are not in there. And they told me 18 study geography, 20 study history. So I can now work out, there must be 5 in the intersection. So there's 5 in the middle. Now I can work out how much are in each of the other sets, because if there's 5 in the middle and 20 do history, there must be another 15 in the history set. And for geography, there's 18 all up, so there must be 13 in there. I now should be able to solve our probability problem. Find the probability that the student studies both history and geography. Well, 5 is in the intersection, so 5 out of 40, 1 in H. So part B then said, well, a student's chosen at random. Given that these students studies geography, what's the probability that the student does not study history? So we know they study geography, but they do not study history. That's what I'm looking for. I can look at the diagram. If we know they study geography, it's now like geography has become the universal set. That's all I'm interested in. And there's only 18 in that. And of those 18, 13 are not in the history set. So it must be 13 out of 18 would be our probability. 2 different students are chosen at random, one after another. What's the probability that the first student studies history and the second student does not study history? So I want probability of history and then not history. There were, let's go back to my Venn diagram, there are 20 students that study history all up. Probability picking someone that studies history must be 20 out of the 40 people. Times, and now I'm going to find the second student that does not study history. Well, there was another 20 students that don't study history, but now it's only out of 39 because I've already picked that other student. So 20, 39, we end up with 10 on 39 for our probability. There we go. So Venn diagrams, it gives us another way of working out our sample space to solve our probability problems.